Welcome surfers, it is Joel and this is Rustlers Atom 2.8. In today's video we talk about the C.O.W, the clone or write that isn't the chess opening by Anna Kremlin but is an enum, a special enum in Rust. If you haven't subscribed to this channel yet, this is the perfect time to do it to support all the Rustlers project. Imagine you are writing a function that usually just returns string slice with no memory allocation. This function is super fast, but maybe in rare edge case, in the same function you need to modify that string before returning it. This is a very common case, for example, when you parse something like a JSON file. In this case, what do you do? Do you return a string every single time paying the heap allocation cost, even when you didn't change anything in the string? Or you return an option string and maybe, I don't know, you force the caller to write some messy logic to handle the non-case? There is a third way in Rust, an idiomatic way. You can use C.O.W, that stands for clone on write. Is a smart enumeration, is a sort of lazy clone. A C.O.W starts as a borrowed reference and stays a borrowed reference as long as you are just reading the data. But at the moment you need to mutate this data, C.O.W clones the data into an owned instance. Let's take a look to a real example to understand how C.O.W works. We can create a sanitize function. So first of all we need to import with use the std borrow C.O.W enum. Perfect. Now I can write the sanitize function that have an input, a string slice, and return a C.O.W str. Perfect. This is the signature of our function. I don't like this space here. Perfect. Now look better. Now if my input contains a bad word, I simply I need a mutation in this case, so I can create another variable that equal input replace or bad word with 4 stars. 1, 2, 3, 4. Okay. And now I can return our C.O.W owned in this case, because I need an owned value because of the mutation. Owned replaced. Perfect. Or with an else, I can simply return a borrowed value because no change needed. So C.O.W borrowed input. This is our code. Now we can try to use this function. I can create a string s1 that do not contain any bad word, so is simply hello Rustlers. Okay, and let the result 1 equal to sanitize our s1 string. Okay, I can annotate something here. Returns a cow borrowed, because in this case no mutation are needed. Let s2 equal to lowercase hello bad word. In this case I have a bad word, so in the result 2 with the sanitize function on s2 I have a unknown value. Perfect. Co-implement the deref trait, so you can treat the co value exactly like the underlying type. So I can simply print these things with no problem. Result 1 is equal to something, result 1, and I can also call a function on this value. So print line result 2 is equal to and its length is result 2 and result 2 dot len. I can treat result 2 exactly like the underlying type. Perfect. Let's try to compile. Okay. I need to remove my semicolon here, okay. And I have an unused value. Why? Okay, let's try to understand. Okay, in this case I simply remove this. The unused value is, I don't know. Try again. Okay, now the compiler have nothing to say. Perfect. As you can see, in the first case I have string slice because this value is not mutated. In the second case I have a known string because the sanitification function change the bad word to this 4-star string slice. And I can call on result to any function that I can call on a string slice. For example, in this case, I call the length function. Okay, for this video, it's all. See you in the next atom. Don't forget to like, to subscribe to this channel, and as always, to keep your thinking cap on.